hello everyone. Hope you had a good lunch. Not too good, but so you can stay awake. So this is the talk about Alexa, your personal assistant. So if you came for the other talk, which was previously in the schedule, you can still run away or simply attend this one. So we're going to talk about voice recognition and how it works. And as an example, I use the stuff that Amazon is selling and providing online. It's not that I work for Amazon or anything. I work for Infosport, a company in the Netherlands. So I've got nothing to do with Amazon. It's not that I try to sell it to you or anything. I'm just interested in it. And I like it because it's fairly open and you can do lots of things with it, as I will show you later. But I mean, the solutions from Google and Apple, you can probably do more or less the same things with it. So for the content for today, this is more or less what we're going to discuss. If you had any questions, feel free to add them in the app and then we'll discuss them later. So first of all, I'd like to explain a bit about what's the Internet of Things, or IoT. I mean, most of the time you have something like a computer with it, a chip, some processing power, and you have a bit of a wire, some internet connection available. But I also was at a conference a couple of years ago and somebody had a really cool idea where he thought of, yeah, I can do temperature sensor and humidity sensor and stuff like that, but normally it's always shown in digits. And older people or people who cannot read digits anymore are confused by it. They have a hard time reading it. So he thought up the solution of showing colors instead of digits. So if it was fairly warm, the light would go red. If it was fairly cold, the light would go blue, etc. I thought it was a really cool idea, so the guy talked about it for, I think, 45 minutes. And then somebody in the audience asked, like, yeah, but this is the Internet of Things track, and how is this connected to the Internet? And the guy said, yeah, basically it's not yet connected to the Internet, and the light is simply changing color at random. So I basically wasted an hour of my time listening to somebody who had LED which could change colors. So if somebody tries to sell something as Internet of Things, be careful that it's not simply garbage with an Internet of Things logo on top of it. This is a bit of a definition I found online, which I think is fairly okay. I mean, Internet of Things is about infrastructure and communication and everything around it. Formerly also known as embedded systems and stuff like that. It's quite the same. But nowadays it's quite popular and it has given it quite a boost since it's called IoT. So what's home automation? So who has automated his home already? So a few people. Okay, cool. But how do you control the Arduino? With a phone or is it automatically? Yeah, okay. Yeah, so most things that we see are still controlled by mobile phones. And we can control all kinds of things like the lights and almost everything. And a colleague of mine actually had quite a nice example, which I like to show. So he had 2 rooms and only 1 television. So he basically made a spinning wall so that he could watch the television both in his living room and in his bedroom. And he could actually, it was a colleague from Belgium, and he gave the presentation in the Netherlands, and he could actually control it from the Netherlands while being away. Oh, sorry, it's on the wrong screen. Thanks for the tip. I hope it is better now. So this is a spinning wall, basically. So is this useful IoT? I would say probably it would have been cheaper to buy 2 televisions, but it's cool. So I also asked him, like, okay, you can spin it around fairly slowly, but can you make it spin faster? Because then you can use it as a fan, and then it's actually quite useful. But he didn't try that yet. And so the talk before was about security of IoT. I mean, if this is hackable, it could end up quite dangerous as well. So basically with IoT you can control anything. Demo you just had. So for me, home automation is like a subset of IoT. It's the stuff you do in and around your house to automate all kinds of things. But there are some challenges with home automation, especially if you do it with your mobile phone, because I mean, mobile phone batteries, they go empty, and you need to charge them, and you cannot use the phone. And with this phone, you probably cannot do much anyway, because it's way too old. Phones, they break. They have the habit of breaking down, and then you're basically stuck with a broken phone, and you cannot control your home anymore. And what is especially interesting is if you're having a discussion during dinner, probably only happens at my place, but we often have a discussion where my wife and I argue and we both think that we are right. Then of course I can take my smartphone out of my pocket and start Googling for it or look it up on Wikipedia, but it's a bit rude to go and play with your smartphone during dinner and your dinner gets cold, so it's not really convenient. And maybe you're at a place where it's hard to reach your smartphone. And so basically, smartphones, they were cool in the past like Batman, but they had their best days, and there's a better solution now. And one of those solutions is the voice recognition service from Amazon. This is an example, the Echo Dot, so this is the hardware that talks to Alexa. And Alexa, it's not a woman sitting somewhere, because then she would be really, really busy, because there are millions of these devices and people. Oh, she's already listening. Millions of these devices, so it's basically a cloud environment with an AI which tries to answer your questions and do all kinds of things for you, which you can also program yourself. So, no, enable it. So for instance, I can ask Alexa, play TuneIn Radio.
Station you listen to, Dance FM UAE.
Alexa, Wikipedia, Java programming language.
Here's the Wikipedia article on Java, the programming language. Java is a general-purpose computer programming language.
So I won't continue this for the rest of the hour. Alexa, stop. Alexa, stop. So you can see you can use it for entertainment, you can use it with Spotify or basically any other music provider. And in between you can ask questions for Wikipedia or whatever. I can also say, Alexa, what's $100 in euro? Alexa, what's $100 in euro?
$100 is 86 euros and 11 cents.
And you can ask other really useful questions like, Alexa, where can I hide a dead body? Alexa, where can I hide a dead body?
I take the body to the police.
Basically, you can do all kinds of stuff with it. And for me, I mean, when this came out, I was like, oh, this is quite cool. I see my slides are not displaying correctly. Let's see if I can fix that quickly. I quite liked it, but for me, it was too easy. I mean, you buy the hardware and it works. I'm a developer, I like to play with things and build stuff myself. So I was like, yeah, it's nice, but what can I do with it? But then they released the instructions to build a device like that yourself, for instance, with a Raspberry Pi. So I brought one with me. So this is a Raspberry Pi at the back with a wireless dongle, a speaker, and by the way, this is not a wireless dongle, this is a USB microphone. So with this, I can basically replicate the device here, and I installed some open source software released by Amazon on top of it, and I can simply use it. You can use big mics, small mics, doesn't really matter. So let's see how it works. For now, I made a connection to it through VNC so that I could connect to the Raspberry Pi, which is underneath it. And I can ask questions like, where's Chuck Norris?
Sorry, I don't know that.
Where is Chuck Norris?
If Chuck Norris wants you to know where he is, he'll find you. If he doesn't, you won't know until it's too late.
So you see now I have to click. Instead of with the other device, I could simply say, Alexa, first turn it off, because else it already responds. And so Alexa is the wake word, then the Amazon device will start listening and will automatically reply. For my Raspberry Pi, I have to click on a button, but they also have released 2 services where you can also do the wake word and you don't have to click anymore. But you have to pay for those services. You can only use them for a couple of months for free, and then you have to pay for it. So I decided to simply keep it like this. And so if you want, you can play with it yourself. All the source is on GitHub. It's all created by Amazon, which is quite nice. And actually, when it came out, at first you only had the really expensive Amazon Echo Dot, which was like $180. So then I created this, which was only like $80, $90 with a Raspberry Pi and everything. So I was like, oh, that's nice and cheap. And then the next week, Amazon released the Echo Dot 2 for only $50. So I was like, okay, bummer. So if we look at it, what solution is better, your own solution, or maybe buy it off the shelf? Own solution, of course, it takes more work. You have to download everything, install everything on your Raspberry Pi, order all the components. Price-wise, it's also a bit more expensive nowadays to buy something like this. But it's nice because you can play around with it. You have full control of it. If you don't trust Amazon that they don't listen to your voice, you can simply program it the way you want because it's open source software. So that's really nice. But the other disadvantage is that Amazon made these Echo Dots really advanced. So there are 7 microphones in it with all kinds of noise cancelling and other stuff in it, which you don't have on your Raspberry Pi. So the Echo Dot, I think, is fairly better hardware-wise than your own solution. But with your own solution, you have ultimate flexibility. Probably for you, most of you, this is not a good idea, but you can do whatever you want with the Raspberry Pi and the Alexa software. And so I told about Alexa for home automation, that it could be a good solution. Instead of using your smartphone, it's better to use something voice activated because then you have no need to grab your smartphone. You can quickly get started. So to show a movie, my colleague made how it worked. So he controls his lights and his sunscreen through Alexa.
Screen.
Oh.
Sending that to IFT.
So you can see his sunscreen coming down.
Hey Amazon, trigger close the sunscreen.
Sending that to IFT.
Hey Amazon, turn on all the lights.
Okay.
So you can see here, this is the traditional interface he used on his mobile phone or on a tablet to control his home. And what he basically did was he coupled Alexa to his existing solution, openHAB, which we will discuss in a minute. So he could quite easily, within, I think, an hour or something like that, add voice control to his existing home automation setup, which is quite nice, I think. And so what is openHAB? Anybody of you using openHAB? Okay, 2 people, nice. So openHAB is a home automation solution which basically creates like a dashboard to control your lights or anything else that you want to automate. So it looks like this. It's in Dutch, but probably it's quite easy to understand. We can control the lights on the table or in the living room, small lights, big lights. We can control the temperature, the volume of the home cinema set, the temperature of the room, the LEDs in the room, and the heating in the sleep rooms, the bedrooms. And so this is a really nice interface which works perfectly on a smartphone, a tablet, or simply on your computer. And it works like this. So all the items that we have, and an item is, for instance, a light or a sunscreen, we can send commands to it, such as on or off, or open it for a certain percentage, and we receive status updates back. So the nice thing is that if I have something where I can press a button, and I can do it with home automation, if I press the button, my home automation setup will get a response as well. So if I turn on the lights with my home automation solution and then turn them off by pressing the button, which is the standard button in your living room, then the home automation display, so this interface, will get an update that the lights are turned off, and it will display that in the interface as well. In the older version of openHAB, which I still use, they have a newer version already available, but this version you had to define quite a lot of stuff yourself, which is of course quite hard if you're not a developer. If you're a developer, it's fairly easy to set up if you have some of the examples, but otherwise it takes a bit more work. But with the new version of openHAB, it's more click and play and drag and drop, so it becomes easier for most people to set up things like this. I couldn't bring the sunscreens because they're a little bit big, so I brought a smart plug, TP-Link smart plug. It's over here, and what it basically does is it enables and disables the power going through. So now I have my laptop connected to it, and if I put it off, my laptop will no longer charge. So I can put it off, and then you can see it's no longer charging. Put it on, and then it's charging again. So I'll also show that in the web interface, by the way. So this is a really simple example of openHAB, simply one switch that I can control. And with this, I can say, okay, power off, and then you can see my laptop is no longer charging. Off. And when I now say, Alexa, Alexa, trigger switch on. Now the status is also updated in the interface, so it works both ways, which is quite nice. So it is on or off. And I did that by using if this then that. Maybe you already heard it when the command was being sent. If this then that is basically a service that if you do something, it will do another action. If this, then that. So if we look at the example, so I created this one, but I will show it live. So there's a website, ifthisthenThat.com, and I can create all kinds of applets, as they call them. So if I click on one of them, and I say configure, okay, so if I say a specific phrase, in this case switch off, then ift will send a command to openHAB. openHAB is my home automation. And it will send the command to this item, basically, and it will send the off command. And it's the same for the, let's see, where's the on? Switch on. It will basically do the same, but then with on. It will send the on command. So that's how I can easily couple my home automation setup with Alexa. And not only my home automation, oh, don't listen. So I can use it for all kinds of stuff. So I also made one with Alexa. I can make a to-do list. So I can say, Alexa, add shopping to my to-do list, and then it's added to my to-do list. But I also wanted to have it available in my email, because I don't have an Alexa with me all the time. So what I created here, let's see, if something is added to the to-do list, then a mail is being sent to my email address, including the latest to-do list. This way. I can do that to my email, I can send it as an SMS. Basically, I can integrate almost anything together with if this then that, which is a really nice solution, and it's free, by the way, so if you never heard of it, check it out. So how does the setup then look like? First, we have the Echo Dot over here, or my Raspberry Pi, which is basically doing the same. When we send a command, so after I say Alexa, which is the wake word, everything after that is being sent to the Alexa cloud. So all the instructions are going to the Alexa cloud. Then Alexa will call if this then that. If this then that will connect to my openHAB, which is the online environment for openHAB. You need to have a my openHAB account to make your openHAB available on the internet. And that's connecting to openHAB, which is running on my Raspberry Pi, and my Raspberry Pi is basically sending commands to my smart switch. When I demoed this at another conference, one of the creators of openHAB was there, and he was like, "Whoa, did you really demo this live?" And I was like, "Why? Don't you trust your own stuff?" Most of the time, it works pretty well. So if I say, Alexa, Alexa, switch off. Oh, no, virus scanner. Alexa, trigger switch off.
Sending that to IFT.
So you can see it's almost instant while I'm going through the internet through multiple different cloud environments, and still it works instant. And I'm connecting all of this with my smartphone, and so it's not like I'm using a dedicated hardware line or anything for it. So it works pretty well. Alexa, trigger switch on.
Sending that to IFT.
So it's already activated again. So I used IFT basically to add extra functionality to my Echo Dot, to the Alexa environment. It's quite annoying. There is another way to add extra functionality to your Alexa environment, and that's through skills. And skills are basically like apps for your smartphone, but then for the voice recognition service. And with skills, you can do almost anything. You can retrieve information, control devices, order pizza, anything. And there is like a store for those skills, just like the App Store. And you can basically download the skills that you want, and you can create your own skills, which is actually quite nice. And I have to say that recently there is also a skill made available for Alexa. So you no longer need to use IFT. You can use the Alexa skill directly, the openHAB skill directly to go from Alexa to your openHAB configuration. So I want to show you a little bit on how these skills work, because I think it's a nice way of playing around and code a little bit. The examples that I give are in Java, but you can do it in Python, in JavaScript, in lots of different languages. So that's actually quite nice to play around with. There are two types of skills, custom skills and smart home skills. The stuff I'm showing now are the custom skills. And there is a little bit of terminology which is quite useful to know, so I'll introduce that first. So maybe you already noticed that if I say something to Alexa, I say, Alexa, ask or tell, then I give it the name. This is basically the name of the skill or the invocation name, and then I give it the command or the utterance. So for instance, if I say, Alexa, ask first to say hello.
Hello from my first skill, which is built at Java 1.
So you see that basically this is now being used, and I will later show the code which is being used for this, and then it explains it even better. Because in the end, the utterance, in this case hello, is being mapped to an intent, and we program against the intents. I'll simply show the code because I think that is a bit easier to understand and less abstract. So we have an intent, and we have one utterance which is mapped to a specific intent. Then there is one class which basically is not doing much at the moment, and one class where all the logic is in. So what I basically do is I implement Speechlet, and then I can override a few default methods. You can choose which ones you want to override and which ones you don't want to override. In my case, I just wanted to keep it quite simple. So I implement the onIntent, and you can see here that I get an intent, and I check if it equals to my first intent. So basically everything, if I say hello, it is mapped to my first intent, and then this part of the code is being called. This part is optional. The cards that you see here, the cards are being used for the interface. So I can see, if I go to alexa.amazon.com, I can exactly see what I've set to Alexa and what the response was. So this is what I asked before, and the response that...
I don't know that.
I don't think I said Alexa, did I? I said it. I just disable it for a minute. And so basically this way I can program, I basically have speech recognition without having to implement anything for it. The only thing I've done is I specified that it had to react on hello. And the rest is being done automatically. So the card here, it's a simple card, and I set the title normal response I don't care about. And I see that here, normal response I don't care about. I can choose to leave it away and don't do the cards, but then I can't see anything in the interface anymore. So it's optional, but it can be quite useful to do this. And then I simply say, okay, return the new tell response with the text which is being put here. So this is everything I needed to make a first skill work. Which for me was quite impressive, because normally I've done things like voice recognition in the past, tried to make it myself when I was at university and had too much time. But it's actually quite hard to do this, and now it's all basically outsourced to the cloud, and the only thing you have to do is give it some simple instructions. So if you want to deploy these skills, so you created the application, and you want to basically deploy the application somewhere, then you can choose to deploy it in AWS Lambda, which is a serverless solution from Amazon, which I also used in my examples. By the way, you notice that it took a little while before it responded the first time. If I ask it again, Alexa, ask first to say hello.
Sorry, I don't know that one.
Alexa, ask first to say hello.
Hello from my first skill, which is built at Java 1.
So now it's instant. The reason is with serverless, after a certain period of not using your application, it's basically passivated on disk, and it has to be activated again. So it takes a little while after you haven't used it for a certain period of time. In my case, after 30 minutes, it will basically put everything on disk, and then you have to start it up again. But that's done automatically for you. So on AWS Lambda, you can use all kinds of different languages. They have support and examples for those languages as well, so you can get started with it quickly. And it's also possible to run the application on your local machine or on some other cloud environment. You can even put it on Azure or whatever you want, basically. So it's completely open, but of course, they try to sell you AWS Lambda because they make most of the money with it. But for home usage, that's not really a problem, because you get like 1 million requests for free every month. And to reach 1 million requests, you can do a lot of fun things already. So I never paid anything for it until now. So normal deployment works like this. So we use a jar file in the case of Java, and we deploy it in AWS Lambda. Then it's simply an application, and what we need to do is we need to create a skill for it. And the skill basically calls the application. And that skill is then used from the Amazon Alexa cloud environment, from my Echo Dot. And it basically looks like this. So if we look at AWS Lambda, we can simply say, okay, create a new function. I can say, okay, here you already see, so there's also support for C#, for Go, and lots of other languages, but I want to use Java with whatever role. I had to give it a name, test GOTO. And now I have a little bit more configuration, and I can upload a zip or a jar file here. So that's all I basically need to do to create an AWS Lambda application. One thing to keep in mind, however, is that after I deploy the application in AWS Lambda, I can create a skill and let the skill connect to my application. However, if you don't do that securely, everybody else can also connect to your skill. Because if they know the address where it's running, they can simply connect to it. And there is quite a simple solution for it. So I use this, which doesn't use any security. And I should have done this, where basically I specify the ID in my application. So in my application, I specify the ID of my skill, and then only that skill can use my application in AWS Lambda. So if you go and play around with this, make sure that you use proper security like this. So although I was like, oh, nice, I can upload a jar file and it works, but if you do continuous delivery or change your application, want to deploy it again, I had to go to the web interface over and over again and upload a jar file, and that felt like ancient times to me. I wanted to deploy the stuff automatically. So I looked around, and luckily there were some Maven and Jenkins plugins available that allowed me to automatically deploy my code to the AWS Lambda account that I have. However, I needed a little bit extra configuration for it. I need a so-called S3 bucket in AWS, which is basically storage in Amazon. And I needed an AWS role, which allowed me to deploy the stuff from the bucket in AWS Lambda. However, those two things you only need to do once, and then you can use it for all the applications that you create and deploy. And the nice thing is then that if I simply call it from Maven, the jar file is being sent to the S3 bucket, it's being deployed in AWS Lambda, and after I create the skill in Amazon Developer, everything works. And creating the skill, I only have to do that once as well. So after I've created that, I can do all the updates automatically. So if we simply pick the example that I've shown before, the simple example, the first skill, and I make it the third skill and do a few modifications. Third skill. My third skill. So this is the Maven plugin I'm using basically to deploy my stuff. The Lambda Maven plugin. And I configure a few things like what the name of the functions should be, a description, how many memory it should use, and what should trigger my AWS Lambda application. And in this case, it should be triggered by the Alexa Skills Kit. Now let's open that in an editor. So let's go back to the fairly simple code. We're at GOTO, so I simply change this to GOTO. So it's basically the same as the example I've shown before, except that I now call it the third one and want to deploy it. For deploying, of course, you need to supply some credentials from Amazon, so I made a script for that so you can see the credentials. So now it will be automatically deployed. Let's go back here. In a minute, we should see the third skill here as well. So now I have a third skill. So this is the application running there. It's simply a Java application running. And if you remember, we need to make sure that I can use it as a skill. So therefore, I can use the Alexa Skills Kit developer portal. So here I have my skills. Oh, wait. I forgot to remove this one, third skill. So now we don't have a third skill anymore. It's simply second skill, first skill, and skills tester. And I want to add the third skill again. My third skill. I want a custom one. I can give it an invocation name, which basically was the name where I'm calling it with. So for the first skill, I said, Alexa, ask first. And first was the invocation name. So now we will use third as the invocation name. And we will add an intent, which is also described here. So we have the my first intent again with hello as the only utterance. So I create a my first intent. And the only utterance was hello. And now I can say build model. Oh, wait. Yeah. It's a bit annoying. You have to press the plus sign before it's added. So now I have one utterance, hello, and now I can build it. And then I need to couple it, of course, to my AWS Lambda application. And like I mentioned, you need basically the location of it, and this is the location. So now you can also connect to this skill if you're quick enough, because you know the location of it. So that's the reason why you need to use security. So let's wait a second until it's built. Okay, so we define the endpoint, our location. So you see I pick AWS Lambda, but it could also pick HTTPS, so you can connect to your own server. I say save endpoints. And then one important thing is that you need to enable the skill for testing, because otherwise you cannot connect to it. And then let's try if we can call it. Alexa, ask Third to say hello.
I don't know that one.
Alexa, ask Third to say hello. So it's again first time we call the application.
My first skill, which is build at GOTO.
So basically now we created a simple application. Of course I reused a bit of the configuration, but that's mainly copy pasting. And then it's running. And if I ask it again now, Alexa, ask Third to say hello.
Hello from my first skill.
So now it's instant, as long as the application is running and isn't put on disk. So the trick is to use it often enough, then you don't have to wait. So there are many possibilities. What I now shown you was fairly simple. So I basically asked a simple question and got the simple reply back. But you can make it a bit more advanced, and I will show that in another example. So now, if I want to ask something to the first skill, I always have to say, Alexa, ask first, blah, blah, blah. But I don't want that. I want to have like a session conversation so that I don't have to say Alexa every time. So if I say, Alexa, ask second random number. Alexa, ask second random number. So you notice that it keeps listening, it's still blue. So I now can say random number. Random number.
32.
Help.
Hello, how can I help you? You can say hello to me.
Stop.
See you next time.
So basically now I'm working in a session and I don't have to give the same instructions all the time. I'm simply logged into the skill basically, and I'm communicating directly to the skill. And that's not really much harder than what we've seen before. We again have the intents. In this case, we have on my first intent another name intent. And you see that I also use some built-in intents, namely the Amazon help intent and the Amazon stop intent. And I'll show in a second where that's for used. My first intent is still used for saying hello. Other name intent is used for requesting a random number. So to first look at the stop and the help intent, so I can simply say, okay, else if Amazon stop intent, then use the stop one. And the nice thing is I can put my own text in here, so I can say a greeting or say goodbye or whatever I want. And I can say, okay, send the response to the user. Same goes for help. But for help, I made it a little bit different. So I basically said, okay, hello, can I help you? But in the end, I say new ask response. So that differs from the new tell response. The new tell response will basically give a response and then it's over. The new ask response will basically give you a session and it will wait for your answer. So that's all I needed to create a session. Only one word that I needed to change. So it's the same for the random number. So if I say other name intent, which was for the random number, then the get random response is being called. where a random number is being generated at a fairly simple way. And I simply say, okay, reprompt, and then ask the response. So that way I can simply keep on communicating with Alexa. So this is one of the ways where you can do more advanced stuff. Here I still use fixed text basically to ask for Alexa, but I can also make this dynamic. So I can, for instance, say, Alexa, what happened on Friday the 13th?
Friday the 13th is a 1980 horror movie starring Betsy Palmer.
Alexa, stop. And so basically I can also supply it with dates and then extract those dates in my application and do something with it. So it's not that you have to do everything like this, you can make it really dynamic. So you can basically have a session, you can do a lot more security if you configure it right, of course. And basically you can do anything with it. It's fairly easy. Everything that you can program in a normal programming language, you can use in here as well. Often people say, yeah, what functionalities do you have? Yeah, basically anything Java offers you, or what Go is offering you, or any other language that you use. And that's really nice. But I mean, of course, sometimes something will go wrong. And this is an example where they used a real plane to simulate what would go wrong if a plane would crash. Because they could simulate it, but you never know if the simulation is working correctly. And it's a bit the same with Alexa. How do you test it? How do you test if your skill is working properly?
I'm not sure about that.
Of course, you can write like a unit test to see if your skill is working, but that's quite silly because then you don't know if the integration with AWS Lambda or with the Alexa developer portal is working, or if anything is working, basically. So I tried to come up with a solution, and that's basically led to Alexa applications talk to each other. So let's see if it wants to work. Ask test to start.
Alexa asks second to say hello. Hello from my second skill. Alexa asks second. Welcome to my second skill. Stop. See you next time. Testing the skill was successful. No issues were found.
So basically, I have an Alexa running on my tablet, and I have one running on the Echo Dot. They talk to each other, and I basically keep track of a list. And I can also show you how it works. So let's see, it's over here. I basically created a list of expected answers, which I use in an intent. So in an intent, I can also use a list of things which are specified. And you can see here that in the answer intent, I use a variable instead of using a simple string. So it basically will, you have access to the complete string, basically. I've got a check object which basically shows the request, the expected response, and the received response, and whether or not the request passed or failed. So then I simply add some stuff, some checks, and I execute one check after the other and see if the responses that I get are correct. So if I change this a little bit and, for instance, make this GOTO, and GOTO, and I deploy that again. By the way, here again in the web interface, we can easily see that the result was successful. I can also see it on my tablet, by the way. So if you have a tablet or an Alexa device on your television, you can see the results visually as well. So if I ask, for instance, Alexa, what's the weather in Amsterdam?
In Amsterdam, Netherlands, it's
I can also see the weather with it. And so if I use Wikipedia, I will get the article as well.
chance of showers.
So let's see if the change skill is deployed. Okay, that's a strange error. Apparently they changed something where they don't allow things that I do now anymore, which is a bit of a pity because yesterday it still worked, but you have to believe me. If I would run it with this, I would get the remark that the first and the third check failed because the answer and the response don't match with each other. So that way I can easily test my Alexa skill, which I think is the only way to properly test it, to know that all the infrastructure in your application is working. So that's basically this tablet and my Echo Dot. And you can, of course, also buy 2 Echo Dots and do this. Don't need to have a tablet for it. But I like to play around with different stuff. You've seen it. So if you want to play with this yourself, if you want to create skills yourself, Amazon created quite a nice GitHub account with lots of Java examples, but also for other languages. If you want to use the AWS Lambda integration, then you can check out my account as well, where I've shown how to use the Maven plugin. So if you buy an Alexa and you want to have a new feature, then I think this is more or less the way to go. Try to find an existing skill if it already suits your needs. If there is no existing skill, try to integrate it with IFT or some other integration service. And if there's nothing available, then you can create a custom skill. Another reason to create a custom skill is, of course, to have fun and do a bit of programming. But if you're on time limits, then this is probably the steps you want to take. So some disadvantages. It's still a bit in the learning curve with Alexa. You notice that sometimes it doesn't really understand me. There are some difficulties with it. It's still mostly in some regions. So in the Netherlands, you cannot normally buy it from Amazon, although some other vendors are selling it in the Netherlands. It doesn't have Dutch speak recognition yet, so there are still some things that can be improved. If you have an accent, you have quite of an issue. You're basically ignored. So if you Google for something and you type in gibberish, then Google will give you the correct answer anyway. If you do that with Alexa, it will ignore you. So that's really something to get used to. There are some clouds, mainly for privacy concerns. People are wondering if Amazon isn't listening to everything you say within your home. But people have checked it as well with network sniffers, and they said that it's quite safe. If you don't trust that, you can build your own device, of course, and implement the software or check the software yourself. There's also one other thing which I found most concerning. That's that to use it, you basically need to couple it to a credit card, and then everybody can use it. And it can distinguish between voices. So if my daughter uses it and does something that costs me money, such as there is a pizza delivery service where you can say, Alexa, order lost pizza again, if she finds out that that works and says it 10 times or 100 times, then I will end up with quite a huge bill without knowing it until there's someone at the door with a lot of pizza. So that's still a bit tricky. I hope they fix that and basically detect who's talking to Alexa, or remove the credit card obligation and only use the free services. But there are also quite some good things about it. Of course, it's new and cool, but it's also quite useful. And you quickly get used to it. My colleague made the movie with the sunscreen and the lights. And when he came home with the Echo Dot, his wife was like, no, another gadget, I don't want it, put it somewhere else. And he used it for around 2 weeks in his living room, and then he had to give the Echo Dot back to me because we only had one at the time. And his wife was saying, hey, can we buy one as well? So for me, that was a good indication that even if you're a non-techie, it's still really quite easy to use, and you get really used to it quickly. I mean, if you want to know something from Wikipedia or other questions, you immediately get the answer. So for me, like smartphones, especially for home automation, they basically had their best day. Voice recognition, I think, works a lot better. So conclusion, for me, it's really easy, it's really open, so you can do with it what you want, and yeah, it's actually quite fun to work with. At least that was my perception. Questions?
So it does not support Dutch?
No, it does not support Dutch.
English only, or?
English, German, and I think Indian, or how you call it. At least in India, it's available as well. I don't know how you call it. It's an Indian language.
Yeah. Does it work over MQTT?
Does it work over MQTT? Good question. I mean, you could use, you could create your own skill and connect that to MQTT, or you could use IFT probably as well to connect to MQTT. So yeah, I would say you can integrate it, but you need some more work to do to make it work.
What happens if you lose your internet connection?
If you lose your internet connection, you lose your Alexa, basically. So the only thing being processed locally is the wake word. So if I say Alexa, that's processed locally. You can, by the way, change it to computer or Amazon. If you have a neighbor, for instance, who's called Alexa, it's quite strange if you are yelling, Alexa, stop, like my colleague had. So he changed it to computer. That's possible, but only to a limited set of around 5 wake words. And that's the only thing being processed on the machine. The rest is in the cloud, so it stops working if you haven't got internet.
So it does require a certain bandwidth.
It does require a certain bandwidth, but not too much. Like I said, everything is now running through 4G on my cell phone, and it's almost instantly responding.
So how much for a starter pack?
So much for?
How much? What are the prices?
Oh, the
For-
price,
for-
sorry.
yeah.
Yeah, so this one is like 50, 60 bucks. So it's fairly cheap. You have different devices. You have bigger ones with better speakers in it. They're, of course, more expensive, but this one is like 50 euros, and you can get started. That's it. So it's fairly affordable toy to start playing with, and look a bit into AWS Lambda, for instance, to improve your programming skills.
Cool. Thank you.
Thank you.